Greetings, ladies and gentlemen. Hope you are doing fine. This is mathematics. In this lesson, we want to look at the question you are seeing on the board. The question is from 2023 GCE Paper 1. This was question number 16. Okay? Please pay attention step by step. I want you to understand everything that will be discussed here. In case you missed one or two, you should be able to get it at the end of the presentation. In the diagram, A, B, C, and D are points on the circumference of a circle with center O. Verify that the information that has been presented here is also turning here. So we are told that these 4 points, A, B, C, and D, are points on the circumference. So we have A, B, C, D. They are points on the circumference of a circle with center O. The circle you are seeing here has got center O. Okay? Further, BD is equal to AD. Where is BD? BD is equal to AD. What does that mean? They are saying this length here is equal to this length. This is the reason why you are seeing this. So don't ignore them. Don't say, no, it was just a mistake that the EC said that meant. No, it's not a mistake. They are communicating. So this indicates that this length is equal to this length. And ADB is equal to 40 degrees. Here it shows an angle. So angle ADB. Where is angle ADB? ADB is equal to 40 degrees. This is the 40 you're seeing here. We have questions here. Find A or B. We have A or B. They're asking us to find this angle. Then BCD. We have been asked to find this angle. OBD. OBD. This angle here. Now, like I always tell you, my students, identify the topic from which the question is coming from. In that case, you will never go wrong. Okay? This question is from a topic called circle theorem. Others would want to say properties of the circle. This is the question. Now, from the topic name itself, properties of the circle, it means there are properties that you're supposed to know for you to answer these questions. It is a very interesting and simple topic. Now, what are some of the properties that you need to understand? Whenever you are given, get me very well, whenever you are given a question from circle theorem or properties of the circle, don't rush to this. Don't do that. Forget about them for now. We are going to put the properties here. Once we put the properties here, then these will just be answers, just like that. But the mistake that some of you make is you want to go straight to A or B, just like the way it is, A or B. You're going to get confused and you will find wrong answers. And whenever you're dealing with this question, have a pencil, okay? Have a pencil, so that you're writing these properties in pencil. You should be using a pencil. Then you just come and use a pen when writing final answers. And when you are showing your work, you use a pen, okay? But when writing properties here, use a pencil. Agreed? Well, we are now going to forget about this. Let's put some properties here. Now, a circle looks like this, okay? We have a circle here. This circle has got this boundary here, which is the length or total distance of the circle. It has a special name. the total length or distance of the circle is called circumference. This is the word you are seeing. So when we say circumference of the circle, we are talking about the total distance of the circle. That is the same as saying perimeter of the circle. So when we say perimeter of the circle, like when we have a rectangle like this, when I ask you to find the perimeter of that rectangle, you're going to say this length plus this length plus this length plus this length. Now look at the circle. It is not, it doesn't have corners like the way a rectangle has. I see that. So what are you going to do? We use a formula on that one, but it is not part of this topic that is under mensuration. Okay, so the total distance, we are saying it is called what? Circumference. Is that point clear? So don't get confused when I'm using the word circumference. You should know that I'm talking about it. That is the reason why here it was said A, B, C, and are points on the circumference. So this is the circumference. So we have got these points. Clear? From there, a circle has got what is that called? The center. This is the center. I am not saying in all the questions you will encounter or you will face, there will be a center. Some questions, there will not even be a center there. They will just be able to give you. We'll look at some examples as we move on. Okay, so now here we have a center here. This is the center of the circle where the length here is always equal from that. Okay, now any line or distance from the center to the circumference, any, it can be like this, it can be like this, it can be like this. As long as it is from the center to the circumference, this length is always called the radius. Is that clear? Radius is from the point, from the center to the circumference. Is it clear? Can we say this is radius from what I've explained? No. Radius should be from the center to the circumference. You can see from here, do we have radii? We don't say radiuses. That is wrong. Radii. Okay? So here we have this, from this center to this. I see that? From this center to this. That is the radius we're talking about. Now, since this is radius, we've got two radii here. Therefore, they are equal because they are the same. I can now say this is equal to this. Just like that. I can make another one from here to there, I join, that will be the same thing. From here to that, that will be the same thing. Is that clear? When you extend this radius, you extend it to the other side, like this. It is now dividing the circle into two equal parts. That is now the semicircle, right? So it's like here, I have got this, then I divide like that. So this line from this point to this point, this line now that divides the circle into two equal parts is now what is called the diameter. So this is the diameter. In short, we are saying 2 radii makes 1 diameter. So if the radius is 2 centimeters, what will be the diameter? 4 centimeters. That is what you need to know. A line that is not passing through the center, like maybe this one, it can be like this, that is called a chord. Not a chord, but chord. So that is a chord. I assume that you understand some terms that I'll be using. we'll be talking about this as we move on. Now, you can see that from this diagram here, we have triangles inside. Huh? We have triangles inside, and we all know that triangles are also in types. We have this triangle here that we are interested much in. A triangle that has got two sides equal. What do we call that triangle? That is an isosceles triangle. Meaning the property that is there is that this base angle, the base angles here are always equal in an isosceles triangle. The two base angles are equal. This, I am able to see it here. This angle will be equal. When you see a triangle like this, what does it mean? All the three sides are equal. It means all the three interior angles are also equal. Each will have 60, 60, 60. This is an equilateral triangle. This is an isosceles triangle, where if this line is equal to this, then these two are equal. Not this one. Applying this here, I'm able to see this triangle, where this length and this length are equal. So if this and this are equal, it means this angle and this angle are equal. Now, in this triangle, I have 40 here. And remember that in any type of a triangle, the three interior angles, this, and this should add up to what? 180 degrees. This plus this plus this, this plus this plus this, 60, 60, 60, 180. This plus this should give you 180. I see that. Now here, we are saying this angle here is 40, and this is equal to this. What do you think will be the size of each? What do you think will be the size of each? For us, when we say this plus this, we should get 180. You can agree with me that each will be 70 degrees. So this 70 degrees is from this point. Let me show you. The 70 degrees is from this point to this point. This is 70. This is also 70, like this. So 70 degrees here, 70 degrees. Where is the 70 coming from? You can say, since 1, 2, 3, they should add up to 180. You can say 180 minus 40. When we subtract the two, 180 minus 40, we are going to get 140. Okay? Now we are saying these two are equal. So you are going to divide this by 2. 140 divided by 2, you get 70. So each will be 70, 70. So that when I add 70 plus 70 plus 40, you get 180. I'm putting the properties here, and it will be very easy for me to find the answer here. The other, before I can shift to other properties, is I've also seen this small triangle here inside. Can you see that? That small triangle is also an isosceles triangle. This is equal to this. This is equal to this. Have you seen that? Now, since it is also an isosceles triangle, it indicates therefore that this angle from this to this end, this angle here, and this angle are equal, because it is an isosceles triangle. So I need to find this angle here, which will be the same as this. For me to get this, I should know this angle here, so that I'll be able to say whatever I'll get here minus 180 divide by 2, I'll be able to get these two. Now the question is, how do you get this angle here? Well, it is now taking us to another property. This property is when I have a circle like this, and I've got a center here. The property says if you've got two radii like this, and they've formed an angle, subtended angle like that, the property says this angle at the center here is twice the angle at the circumference. So there is this property somewhere here. Angle at the center is twice the angle at the circumference. I've got another one here. Center here, we have this, and this. This angle here again will be, if I've got something like this angle here will also obey the same property with this angle. I hope this is clear. This angle is twice this angle. That is the property. This is applied here. You can see this angle I want and this angle. There is a relationship. This should be twice the angle at the circumference. So if this is 40, then this will be what? Twice 80. So this one will be 80 degrees. Please, they are in opposite. This one, not the one here. This one. Here, it will be this and this one. Not this one and this one, no. So, here, it will be what? It will be 80. Because here it is 40, multiplied by 2, gives you 80. Now that I know that this angle here is 80, it is now easy for me to find this angle here, which will be equal to this. Remember, the 70 is from this end to this end. Now I want from this point to this point for the small triangle. For the small triangle, which looks like this. The triangle looks like this. So here it is 80. I want this and this, that will be equal. So from this small triangle inside here, I want this. What will be that? I'll be able to say 80, 180 minus 80. It will be 100. Eh? Now we are saying they are equal. It means these two are equal. We are going to say 100 divided by 2. It will be 50. Therefore, this will be 50, this will be 50 here. So, from this end to this end here, it is 50. Even here, from this end to this end here, it will be 50. So 50 here, 50 here, 70 is from this end to that end. Now, you can see that from this end to this end, this O angle here is 70. And from here to there is 50. What do you think will be the size of this angle? 20 degrees, right? So even here, this angle will be 20 degrees. Why? Because the whole angle here is 70. Then from this to this is 50. From this to this will be 20. 70 minus 50, that is 20. So this will be 20. Are you with me there? I think having said all that, we can now shift our attention to the questions and see if you can get them. A says we should find A or B. Angle A or B. Let's go to A or B. A or B. What is the answer? You have already done the work. The answer there is what? 80 degrees. Done. B. These things are simple. B, C, D. B, C, D. Let's go to the diagram. B, C, D, which is this angle here. How can we get that angle? We are going to introduce another property that we have not used here. Okay? we are going to introduce another property that we have not used. This is the property. Look at this. Here is a circle. And then in this circle, I'm going to draw a four-sided shape inside. I can say this, okay? Then this and this. Four-sided shape inside, which is called now the cyclic quadrature, okay? So we have four-sided shape inside cyclic quad. So the property which is there is that this angle here and this angle, when you add them, you should get 180 degrees. Same, this angle here and this angle here, when you add them, you should get 180 degrees. That is the property. I'm able to see that. For me to get this, I should use this. Of course, there are different methods that can be used. So I can say, for me to get this angle here, I can see this four-sided shape inside. 4. I see that? 4. So this one and this one here. This one and this one here. This angle plus this angle, I should get 180. Okay, I'll be able to say, I know the angle here. From this end to this end, we said it's what? 70, right? So this is 70 here. For me to get this, what am I supposed to do? 180 minus 70. This one will be 180 degrees minus 70 degrees. And this will give me 110 degrees. I'm done. So this is 110 degrees. The last part there, C said we should get OBD. OBD. What would be the correct answer? Let's go to the diagram. OBD. We have already calculated. The answer is what? 20 degrees. This is the 20 here. So, ladies and gentlemen, go through, watch the video so that you understand the few things I've said here will definitely going to help you. It will work out. So make sure you go through this. And in the other next video, I'll explain the remaining parts of the properties. Then